Welcome to the lesson on surds. In this lesson, we are going to look at three things. Number one, simplifying a surd. Two, rationalizing a surd. And also you're going to look at the conjugate pairs. So we begin with some starter questions. Use the calculator to find the values of the following. So use your calculator and you find the root of all these from number 1 to number 6. Now what do you realize when you do these computations? Number 1, you realize that some of them have got exact roots, like 36, like 144, cube root of 8, the fourth root of 16, and so on. But these two, for number 5 and number 6, these ones do not have exact roots. Root of 2 is 1.41. The cube root of 21 will give us 2.76. So let's go to the laws of surds. By the end of the lesson, we should be able to explain what a surd is and also to investigate the rules for the surds. The outcomes for the lesson is learning the rules for surds, using the rules to simplify the surds. So let us begin with the meaning of a surd, understanding what a surd is. For proper understanding of a surd, we are going to use these two examples that are here, actually these four examples. Number 1 is root of 36 will give us 6. Root of 144 will give us 12. So you realize that these two have got exact values and they are called rational numbers. But for the ones that are below here, that is the root of 2 and the cube root of 21, they do not give us exact values. So those ones are called irrational numbers or surds. So that is the whole meaning of surds. So in this topic we are going to deal with surds, and we'll be having numbers like root of 2, root of 5, root of 3, and so on. So let's begin with addition and subtraction of surds. Now when you are adding or subtracting surds such as root of 2, root of 3, root of 5, it can be treated in the same way as an x variable in algebra. Now the following examples will illustrate this point better. So when we are adding or subtracting surds, what we do, we replace or substitute the surd with any variable, either x, y, any algebraic variable like x, y, z, and so on. So in this case, I'm going to replace this surd root 2 with x. So instead of writing root 2, I'll substitute this one with x. So I have 4x plus 6x, which will give me 10x. And I remember that my x is root of 2, and in my final answer, I should be able to write it as 10 root 2. In this example, my surd is root 23. So I replace this root 23 with any algebraic variable. So I use x. So this one will be 16x minus 7x, which will give me 9x. Then I remember that I have substituted my x with root of 23, so I have my answer as 9 root 23. So that is how we add surds. Now one important thing that we must understand is that when you are given root of 2 plus root of 3, that one does not equal to root of 5. Roots can only be added if they are identical. Like these ones are not identical. Root of 3 and root of 2 are not identical, so we cannot add them, and that one is not equal to 5. We can only be able to add the one that are identical, like this one, root of 2 and root of 2, root of 23, root of 23. But we cannot add maybe root of 2 and something else like root of 3. That one is not possible in surds. So we go to the rule, the first rule of surds. Now the first rule of surds states that if you're given root of a times root of b, that one is equal to the root of ab. Using examples to illustrate this rule, let's assume our a is 4, our b is 6, so we have root of 4 times root of 6 will give us root of 24. Another example, root of 4 times root of 10 will give us the square root of 40. So when you're given any root of a, any root of b, and multiply it, you should get the square root of ab. List down the first 10 squares of numbers. This one will be very helpful when it comes to simplifying of surds. Like the square of 1 is 1, the square of 2 is 4, the square of 3 is 9, the square of 4 is 16, the square of 5 is 25, the square of 6, and so on. This one will be very useful when it comes to simplifying the surds, and that is what I want us to look at, simplifying surds. Now, some square roots can be broken down into a mixture of integer values and surds. The following examples will illustrate this idea. If you are to simplify root of 12, the first thing, we must split 12 into factors with at least one being a square number. Let's say 12 can be broken down into 1 times 12. And when you look at 1 times 12, there's none of those numbers that you can get the square root of. You can also break it down to 2 times 6. When you look at 2, you cannot get the square root of 2. You cannot get the square root of 6. So when you're breaking down these numbers, one of them must be a square number. Like in this case, 12, we look for a number like 4 times 3. Now when you look at 4, we can be able to get the square root of 4. 3, we can leave it like that as a surd. So we write 12 as 4 times 3, so it will be the square root of 4 times the square root of 3. That is what gives us the square root of 12. And the square root of 4 is 2, and the square root of 3, we leave it as a surd, which now the answer will be 2 root 3. More examples. Root of 45. Simplify the following surds. Root of 45. So break down 45 into two numbers, whereby one of them must be a square number. So we breaking down, this one will be 9 times 5. So 9 is a square number. So we get square root of 9 times the square root of 5. The square root of 9 is 3, and the square root of 5, we leave it as a surd, so the answer will be 3 times root of 5. 32, the square root of 32. Break down 32 into two numbers, whereby one of them must be a perfect square or square number. So 16 times 2 will give us 32. So we get the square root of 16 times the square root of 2, and the square root of 16 will give us 4. The square root of 2 will give us root 2. So we leave the answer as 4 root 2. For the square root of 72, the same way, we can break down 72 into 4 times 18, which will give us 72. So we get the square root of 4, we get it as 2. 18 can also be broken further into 9 times 2. Can be broken down into 9 times 2. So we have 2 times root of 9 times root of 2, whereby we get 2 times the square root of 9 is 3, and the square root of 2, we leave it as a surd. So we get this as 2 times 3, which is give us 6. 6 times root 2, we get a 6 root 2. Now what goes on in the box? The box, how do we arrive to these answers that are here? Now the square root of 20, we go the same way. You're going to treat this one the same way. The way we have done in the previous slide, we look for two numbers that one must be a square number. Like in this case, 20, root of 20, you can think of 4 times 5. We get the square root of 4, and we get that one is 2, and then root of 5 remains to be like that, and so on. So let's see the solutions. Solutions for these, we have already done this. So we go to number 2, root of 27. These two numbers are root of 9 times root of 3 will give us root of 27. The square root of 9 is 3. This one is the square root of 3, that is cube, that is 3 root 3. We go to the next one, root of 48. We break down this one into 16 times 3. So the square root of 16 is 4. The square root of 3, that one you get is 3. The next one, number 4, root of 25, root of 75. We can break down this one into two parts. 25 times 3, we get the root of 25 as 5. The root of 3 will remain to be like that, and this one will give us 5 root 3. 4500, break down, this one is quite a big number, so we can break it down into 900 times 5. That is what will give us 4500. So the square root of 900 will give us 30, and then the square root of 5 will remain to be root of 5. So the answer is 30 root 5. 3200, also another big number. We can think of two numbers to split this one, to break down this one. 1600 times 2 give us 3200. So we get the square root of 1600 as that one will give us 40. times the square root of 2. More questions? We can try to do all these questions. Maybe we can look at these ones where we have fractions. Remember that a half times a half is a quarter. So for number 4, when you are multiplying surds, you're going to see in our next rule, root of 4 times root of 4 will give us 4. The reason is because when you get the root of 4 times the root of 4, you get the answer as root of 16, and the root of 16 is 4. So the answer here is a quarter. The laws of surds. You're still on the laws of surds. In this part, I want us to explain by the end of the lesson, or by the end of this chapter, we should be able to explain how to rationalize a fractional surd. The learning outcomes, we should be able to understand that root of a times root of a will give us a. Root of a times root of a will give us a. For example, root of 2 times root of 2 will give us 2. We should be able to understand, to be able to rationalize the numerator or the denominator of any fractional surd. The second rule is what we have just looked at. The square root of a times the square root of a will give us a. Examples to illustrate these: the square root of 4 times the square root of 4 will give us 4. The square root of 13 times the square root of 13 will give us 13. Rationalizing surds. Now you may recall from our fraction work that the top line of a fraction is the numerator, the bottom is the denominator, as you can see here. So fractions can also contain surds. In this, root of 2 divided by 3, 5 divided by 4, root 7, and so on. So let us see how we rationalize the surds. Now, if by using certain maths techniques we remove the surds from either the top or the bottom of a fraction, then we say that we are rationalizing the numerator or rationalizing the denominator. So simply, rationalizing means removing the surd either from the numerator or from the denominator. Removing, the process of removing that surd is what we call rationalizing a surd. Now remember this rule, because you're going to apply this one in our examples. The square root of a times the square root of a will give us a. This will help us to rationalize a surd fraction. Now to rationalize the denominator, multiply the top and the bottom of the fraction by the square root you are trying to remove. Now let's say we are supposed to rationalize this. 3 divided by root 5. We have said rationalizing is removing that surd, getting rid of that surd, either from the numerator or from the denominator. So for us to rationalize these, we want to remove this surd from the denominator. So we are going to multiply both the numerator and the denominator by that surd we want to remove. So we multiply the numerator by root of 5, the denominator by root of 5, and we have seen in our previous example that root of 5 times root of 5 will give us 5. That is the second rule of surds. Root of a times root of a will give us a. So this one, 3 times root of 5 will give us 3 root 5. Then root 5 times root 5 will give us 5. Let's try this one. Remember, multiplying top and bottom by a root you are trying to remove. Multiply the top and the bottom by root you are trying to remove. So in this case, I want to remove, to rationalize this denominator, to remove this surd, this root 7 here. So what I'm going to do, I'm going to multiply both the numerator and the denominator by that surd. So 3 times root 7, 2 root 7 times root 7, and this one will give me 3 root 7 divided by 2 times 7. We've just said that root of 7 times root of 7 will give us 7. So we get the answer as 3 root 7 divided by 14. Now let us rationalize the denominator again, do more examples on these. So we want to rationalize the denominator, so we want to remove this root that is here. So we multiply both the numerator and the denominator by this root that we want to remove, that is root 5. So 10 times root 5 is giving us 10 root 5. Then 7 times 5 times root of 5. Remember, root 5 times root 5 will give us 5. Then this one will be 7 times 5, which will give us 2 root 5 divided by 7. So we have done some simplification here. This one by 5 1, by 5 2. That is why we have 2 root 5 divided by 7. So this is some simplification that we have done here. So again, what goes on in the box? I want you to try this one out. Try these examples and see whether you're going to get these answers that are here. As you've said, we are going to ensure that we divide or we multiply both the numerator and the denominator by the root that you're trying to remove. Like in this case, we are going to multiply the top, that is the numerator and the denominator by root of 3. In this case, you're going to multiply the numerator by root of 6 times root of 6 and so on. So try to do the others and see whether you get these answers that are indicated there. Some questions again. Multiply out root of 3 times root of 3. Remember that one you've said root of a times root of a will give us a, so this one will give us 3. Root of 14 times root of 14 will give us 14. Then for this one, this is what you're going to use in our conjugate pairs. Root 12 plus 3 into brackets root 12 minus 3 will give us 12 minus 9, which is given as 3. Now when you look at these, you can simplify this one by expanding, or you can simply recall that this one is a difference of two squares, whereby you're going to take this one as 12 root 12 squared, which is 12, minus 3 squared, which is 9, and this one will give you 3. Difference of two squares, you can recall that one from form 2 work. The laws of Surds, we're continuing with these, but now we're going to look at the conjugate pairs. Now the learning intention to explain how to use the conjugate pairs to rationalize a complex fraction or Surd. Success criteria by the end of this chapter. We should be able to know, this one is very important when you are rationalizing, that root of a plus root of b into brackets root of a minus root of b, this one is equal to a minus b. And I've said that this one, you can recall, this one is a difference of two squares, or you can expand. When you expand this, you get the answer as a minus b. Then you should be able to use the conjugate pair to rationalize complex fractional surds. Now, as you've said, when you are rationalizing the surds, we look at it as a difference of two squares. When you look at this example that is here, when you look at this expression, root of 5 plus 2 into brackets root of 5 minus 2, this is a conjugate pair. The brackets are identical apart from the sign in each of the brackets. So when you look at this, everything is identical, root of 5, root of 5. But the only difference is this sign. This is plus, this is minus, this is negative. So this is what we call a conjugate pair. One is positive, everything is identical, but the only difference is that one of them has a different sign. So when you want to work out this one, I said we can just go the long way by expanding, or by just remembering that this one is a difference of two squares. So to multiply these, we just take root of 5 multiply by the root of 5 will give us this have here. Then root of 5 times negative 2 is the one that you have here. Then we go to this, we take this one, 2 times root of 5, get this, and there's a negative sign between there. Then 2 times negative 2, that we get negative 4. So when you multiply this one out by expanding, you'll get 5 minus 4, which is 1, because this is root 5 times root 5 give us 25, root of 25, which is 5, and then negative 2 root 5 plus 2 root 5 will give us 0. This part will give us 0. So we'll have 5. The answer for this one will give us 5, and then minus 4, which is 1. So that is how we multiply such a conjugate pair. But the easiest way is to just remember that when you are multiplying the conjugate pairs, this one looked like something to do with the difference of two squares. And how do we deal with the difference of two squares? You just need to take this root 5 squared minus 2 squared. So root 5 squared is 5, then minus 2 squared, which is 4, and that one will still give you 1. So when the brackets are multiplied out, the surds always cancel out, and we end up seeing that the expression is rational. No root sign again. So when you multiply these, the root sign disappears. So we go to the third rule, and the third rule is what you have just looked at previously. That rule states that if you have root of a plus root of b into brackets root of a minus root of b, this one simplifies to a minus b. And you have seen how we work out this, how we expand this using the difference of two squares or the long way. So example to illustrate this, root of 7 plus root of 3 into brackets root of 7 minus root of 3. This one will give you 7 minus 3, which is 4. Just use the difference of two squares. Root 7 squared is 7. Root of 3 squared is 3. And 7 minus 3, you subtract, you get 4. The same way to this, for you to expand this or to work out this, you just need to take root of 11 squared will give you 11. Then subtract root of 5 squared will give you 5. And 11 minus 5 will give you 6. So rationalize the denominator in the expressions below by multiplying the top and the bottom by the appropriate conjugate. So we want to rationalize the denominator. In this case, for us to rationalize this denominator, we are going to multiply both the numerator and the denominator by the conjugate of the denominator. We have just talked about the conjugate pairs, and you've seen that the conjugate pairs are identical. The only thing that is different is the sign. So the conjugate of the denominator will therefore be root 5 plus 1. Root 5 plus 1. And that is what you're going to multiply with, both the numerator and the denominator. So when you do this multiplication, this is what you'll get. For the numerator, we'll have 2 into brackets root 5 plus 1. The denominator, we shall have this root 5 minus 1 multiplied by root 5 plus 1. This is the conjugate pair, and you have seen how to work that one out. For us to work this one out, the easiest way, we just pick root of 5 squared, which is 5, minus root of, this is 1 squared, and will give us 1. So we'll have, multiply this one out, you get 2 into brackets 5 root 5 plus 1 is equals to that, then divided by this one will give us 2. Where do we get these 2? It has been simplified. Once you subtract these, 5 minus 1, you get 4. So you cancel out by 2, 1, then 4 divided by 2, you get 2. That is where we get these 2. So the answer is root 5 plus 1 divided by 2. Rationalize the denominator in the expressions below by multiplying the top and the bottom by the appropriate conjugate. So we want to rationalize the denominator. So the conjugate of the denominator will be root 3 plus root 2, and that is what you're going to multiply with both in the numerator and the denominator. The conjugate of this denominator will be root 3 plus root of 2. So we work it out. The denominator will be, we say the easiest way to do this is to remember that this one is a difference of two squares. So you have root of 3 squared. Root of 3 squared will give us 3 minus root of 2 squared will give us 2. So the denominator will be 3 minus 2. Then the numerator will be 7 into bracket. This is a 7. You can open it to be 7 root 3 plus 7 root 2, or you can just leave it like this bracket. So 3 minus 2 is 1. and therefore the answer will be 7 into brackets root 3 plus root 2 divided by 1, which is, you can just leave the answer like this. Now you can try these assignments. That is the end of our lesson. So for proper understanding and application of those rules that we have just looked at, you can try to do all these examples. The answers are provided here. Just try to work to rationalize. Remember the rules of surds. Remember how we add the surds. Remember how we rationalize the denominator, and so on. So thank you so much for watching, and have a good time.